Okay, so would you fall for the placebo effect? Hopefully you already watched the video. So what do you think the people or the guy in the video, why do you think he got stronger? So one reason is that just the thought of improved performance helped him improve. That's the placebo effect. So it's kind of like a mind over matter thing. Okay, so similar to this video, Mr. McBurney wants to use a beverage to test the effects that caffeine can have on heart rate. Here's his initial plan. Measure the initial pulse rate, give the student some caffeine, let's say Coca-Cola, wait for a certain amount of time, and then measure the final pulse rate. And then you compare the final and initial rates. So what are some problems with this plan? So it's not an actual experiment. The reason is we don't have some things. So let's talk about what are some problems. So one problem is anxiety. Anxiety causes your pulse rate to go up. So maybe being put into a different group could cause them to have anxiety. What about movement? What about a person's genetics? So some people are just sensitive to caffeine. Or it could also just be the sugar that's in the caffeine or that's in the Coke. So all of these, I'm going to leave some space, all of these are called confounding variables. So number 3 says go back to your list and number 2 and propose a solution for each of these problems. Okay, so anxiety. If we split the group up so that we have a control and someone actually getting the treatment, then we'll have a placebo, and that'll kind of separate them evenly. So you have some people with anxiety in both groups, so that way it limits the confounding variable effect. Movement, we want to keep them seated. Genetics, again, placebo. If we have that placebo or we have that control. Same thing with sugar. If we have a placebo or a control, we can kind of move those around evenly. So all good experiments will try to limit those. Number 4, ask us to design an experiment to test the effect that caffeine has on our heart rate. So we're going to draw a diagram. So you're going to take some students, let's say it's 100. You could do different numbers. You want to take the initial pulse, then randomly assign into 2 groups evenly. One of them gets the treatment, one of them gets a placebo, and then you take the pulse and compare it to the initial pulse. That would be an experiment. So let's look at some vocabulary. So control group, used to provide baseline data for comparison. If you have nothing to compare it to, it's not an experiment. So our control group gives us our baseline. Blinding, there's 2 types of blinding. You can just make it where the subjects don't know, or you can make it where the subjects and the researcher doesn't know. So when subjects, this is called single-blinded, or experimenter or researcher is also not in the know. It's called double-blinded. They do this a lot in medical studies because they don't want the researcher or the doctor to influence the results, because they can influence the results by asking particular questions to whoever's taking the new medicine or whatever. So you want to make sure that there's no bias interjected in there, so that's why you would do a double-blinded. Placebo effect, when a treatment or placebo, or fake treatment, sorry, when a fake treatment called a placebo works. So that's going to be our control group. They don't know, though. They're blind. When an observed difference in responses between the groups in an experiment is too large to be explained by chance, we say that the result is statistically significant. So that was like our smelling Parkinson's. There was no way by chance she could guess all of those. So it's statistically significant that Joy guessed all of those correctly. Okay, so this is a review, random assignment. You'll want to label. So you'll label your units or your subjects with numbers. So whether it's plants, whether it's cows, whether it's people, you need to label them so that you can randomly generate them. So randomize, we're going to use a random number generator, or you could do pieces of paper that you pass out. That say group 1, group 2, group 1. And so it's spread out. And then you would select corresponding to the numbers that you generated, and then repeat if necessary. So key principles of experiments. This is important. It needs to have all 4 of these things. So the first one is comparison. If you don't compare, it's not an experiment. 2 or more treatments. So you can't just do one treatment and say it's an experiment. You have to have something to compare it to. Randomization, randomly assign. And then it's important to have a control so that you create that baseline or find that baseline. Keep all other variables beside treatment constant. So whenever you have a control, you're spreading out those confounding variables between both groups. So this is to minimize confounding variables. And you can't just do it one time. You have to do it multiple times. So this is replication. Or maybe you just do a large sample. That's also replicating it. So use enough experimental units to distinguish differences. So that's replication, large sample size. So if they just do it with 12 subjects, is that enough? I don't know. It depends, but I feel like that's not enough. All right, so let's look at the application. A group of researchers in Africa find a creative way to protect cattle from lion attacks. They paint eyes on the cows' rears. To determine if the treatment is effective, they randomly assign the cattle to one of the 3 treatments: eyes on the rear, cross marks on the rear, or nothing on the rear. After 4 years of roaming the plains, the cows with eyes saw no deaths. The cows with crosses suffered 4 deaths, and the cows with no marks suffered 15 deaths. So you're going to go through and answer these questions. Explain why it's important to have a control group that didn't get a mark on their rear. B, suppose the researcher had 1,200 cows. Describe how to randomly assign the cows to those treatments. C, what is the purpose of randomly assigning treatments in this context? And then D, create an outline showing a completely randomized design for this experiment. Okay, so let's look at part A. Explain why it's important to have a control group that didn't get a mark on their rear. Anybody want to share that?
In order to minimize the confounding variables.
So minimize confounding. What else though?
To prove that something changed.
How do you prove that something changed?
The control of this happened and the variable that happened.
Yeah, the control gives a baseline.
Yeah.
Control provides baseline. Because you need to see how many deaths there are in general, right? So, and then minimizing confounding variables. So why is it important? That didn't get a mark on the rear. So this is actually an answer to why do we have 3 treatments? 3 treatments. Maybe not. I don't know if I like that. But the provides a control, a baseline, that's the better answer. So if this was a multiple choice and you had both of those answers, you would want to pick provides baseline.
Would they mark off points if we wrote the top one and not the bottom one?
Explain why it's important to have a control group. Because I don't think that actually answers it. We definitely need to minimize confounding factors. And we do that by putting them into groups. That's how we minimize controlling. So putting into groups.
So if you put limit confounding variables for C, that'd be right. That's what.
Yes, yeah. So that's more of a C. Okay, so how are we going to randomly assign 1,200 cows to the treatments, to the 3 treatments?
Label all cows.
Okay.
100,
Yep.
1200.
So label all cows 1 to 1,200. Okay. Then step 2.
Randomly generate 400 numbers from 1 to 100.
What do we need to know about those 400 numbers? Distinct. Yep. To get 400, let me erase that. Distinct numbers. Distinct or unique numbers. You can also put 400 numbers, no repeats. Okay, after you get your 400, then what do we do?
Assign that to one of 3 groups.
Okay, so select first. Select what? Corresponding cows. And we need to go ahead and assign them, right? Put them in a group. And put in, let's say group 1. What do we want group 1 to be? We get to decide. Okay, no mark. Okay.
Repeat
Yep, repeat
for all groups until all the cows are assigned.
for, let's say for group 2, which gets eyes. And group 3, which gets the crosses. But you want to make sure you don't repeat anything. So I'm going to put on there no repeats. So it's like you pull out that number and it's gone. So I think you can do that with some random number generators. It'll make it where those numbers don't come back. Okay, so what is the purpose of randomly assigning treatments in this context? Limits. No either. Confounding variables. What would be some confounding variables here? What do y'all think?
Pattern genetics, like they have a pattern on there where that looks like eyes already.
Okay, so their coats.
If there's like one family of cows that's like really fast.
Oh, yeah, speed,
Like 8.
age, size, yeah. What about health? Because they might just be old and they die because of that. So if we disperse them evenly, then that limits those confounding. All right, so now we've got to create the outline. This does not give much room. But what do we start with? Okay, so 1,200 cows. That's a weird Z. 1,200 cows, what are we going to do with them?
Randomly assigned.
Label.
That's part of the randomly assign. Randomly assign, what are we assigning them to? Our 3 groups. Okay. After we randomly assign them, what do we need to do to them?
Paint eyes, crosses. And
Yeah. So, did y'all make another column or did y'all kind of put it with it?
I put it with it.
With it or a new column? Totally fine, either way. So this one would be nothing, basically. And then what do we have next? Eyes. Paint eyes. And then this one is paint crosses. After you do that, what do we do? Yeah, compare deaths. All right, and so we have our explanatory would be what's painted on their butt, if anything's painted on their butt. And then our results, our outcome would be how many deaths there are.